Okay, so ladies and gentlemen, here we're going to get started on this model. So first thing I'd like you to do is to go save this model as an alternative model, okay? And I would like to propose you say step 4 input output, okay? So it's wedged, Merlin. I tried to start the ad hoc recording, filled in all the action, and it got wedged.
What did you propose the name?
I proposed step 4 input output, okay? The next thing I'd like to do is to do the following. I would like to go, and we're going to go down to the level of city. We're going to put in place something which we've seen before, which is a statistic, okay? And the statistic is going to compute at the city level. It's going to compute prevalent case count. Prevalent case count, okay? Okay. And this is going to count up the number of people who are infected in the city population. So does anyone want to tell me what to type there? Well, remember, this is for a city population. Each person in the population has a state chart, which basically says exposed, infected, susceptible, recovered. And we want to total up the number of people, ladies and gentlemen, who are infected. How do we do that? What do we do here for the statistic? So, sorry?
Could you do in-state?
Yeah, exactly. And what do we ask if it's in-state? It's what? Here it's actually item. Remember, you have this little hint in the form of this light bulb. Item dot in state, and this is Merlin. This is called model input output. In state, and the safest way to say is person dot infective, because it's infective state with respect to person. That's the thing that zapped Cheryl.
Length of time?
You could just leave it as that. Thanks. Okay. Okay. So, ladies and gentlemen, let's run the model now. Note we have this population, this computed at the level of the city. So we're going to start running it. Do you understand why it got wedged, Merlin?
No.
Okay. Okay, ladies and gentlemen. So I like this in-class exercises there. Yeah. Thanks. Yeah, that's what I need.
So
Yep.
this is being recorded on the software. You realize that, right? So your oh, you haven't actually got this recorded.
No, I don't want it
You're
recorded.
good. Okay,
Yeah.
good.
Yeah.
You're good.
Okay, so ladies and gentlemen, as this runs, we'll see the city population. If we want to see the statistic, where do we go? Yeah, city population, and here we'll see the prevalent case count in this city. Right now it's 2, 1, 3, 6, etc. Okay, so this is a depiction of that particular city. Thanks, Merlin, and successive cities. Okay. Okay, great. Let's go beyond that, though. There's a couple things I want to do that are going to be illustrative. The first thing is we're talking about model input. I'm going to take us a place where no one in the room, except maybe Kurt, is gone. Maybe, I'm not even sure Kurt is explored there. Okay, so ladies and gentlemen, I'd like to go to this database. Okay? Okay.
I've explored it as a result of helping another person.
Okay, great.
Only not 2 hours
Okay.
since.
Okay, good. Well spoken, young man. Ladies and gentlemen, select the database, And I'd like to check here log model execution. Okay, this is gonna clue us into some ways we can collect information on a model. Okay, on a model's behavior. Okay, log model execution. Now, if we run this model now, you'll notice it's materially slower. So I would run the same scenario again, and we're going to let it run for a little bit, and we're going to see what setting hath wrought. Not going to be outdone, Kurt. Yeah. Okay, so we're running it here. And proceeding now. I don't know if you can see that, the virtual time. We're running at full tilt. It's proceeding with the infection more slowly. And that's because there's a lot of recording going on. The model is saving away results to a database. Okay? And as we'll see, that database is going to contain some pretty useful information, but we're going to be able to rest that database to contain a broader set of information by selectively adding things to this model. I want you to see the database in its rawest form, in its most raw form. Yeah, okay. Okay, great. So, ladies and gentlemen, we can stop model execution and terminate here. And you'll notice it takes a bit of a longer time to stop as well. I'd like you to go down to the database, and you'll notice underneath the database now there lies a log. Okay? And expanding the log beneath it, we'll see a slew of different particular detailed logs. I'd like you to double click on one of them. Without privileging it, let's choose the agent log. And you'll notice that when we double click on it, it says query data. And then over here to the right, we can see information about messages, who is the recipient, who is sender of that message, and the time in which it was sent. Okay? This provides sort of an audit trail, a forensic record from the model as to the messages sent in that model. Okay, we can look further into this. I'd like to look state chart states. Okay, and we can double click on that, and here we see information on particular persons, the state involved, the entry date for the state, and the exit date for the state. Okay? The time when they entered that state and when they exited that state. State chart stats as well can provide some additional information. You'll notice that here we have some information, sort of the amount of time. I believe this is the amount of time they've spent in certain states here. Although I'd have to double check that, because there's some of these which relate to transitions here. Okay, but this is some statistics involving presence in state charts. I'd like you to take a look at the agent log, which is going to indicate the agents that were created by the population. Here was a set of city agents. There was Maine, but then there were a set of person agents as well. They had a birth date. There were no agents in this model, so there's no death date from them. And all the birth dates, it turns out, are the same. And so, sorry, Cheryl?
Sorry.
Isn't that interesting, though?
I was just mumbling, it was cool.
Yeah. So if you double click on events, you'll see that it records here all the events occurring in the model. Here's a migration event. For example, you remember in this model, we had individuals who were subject. Here's their migration event. Do you remember that? It moved them from one city to the next, did it not? And here's the migration event, and here's the agent. And you can see the agent associated with this was a city's. This was occurring in a certain city. Okay, and it was occurring to a person in this city. Okay, at this certain time. There's additional events as well, many of them for features which lie not yet in this model. There is a trace event, and that can allow for some tracing of the model. Okay, but in short, this log has many types of data associated with it. I actually want to get on to other elements of the data import and export into the database. But I would note that when it comes to the database, if we click on it, we can export tables to Excel. So we can export that data, and we could choose what data we wish to export. And we can also indicate if we want to export these tables on a regular basis, say at the end of model execution. Okay, so that would allow us to report this sort of trace of the model. Now, I'm proud to say that there's strong lines of evidence to suggest that this feature of AnyLogic logging came out of conversations Jeff and I had with the AnyLogic team, and particularly out of the work of a master's student here, Priezri Bomik, who created a tool to do this sort of logging, an external tool to AnyLogic. And we argued to them that in the health area, being able to have a longitudinal view of the changes a given agent experiences over its life course is advantageous. You know, if you want to understand so from a life course perspective an agent's encounters, or if you want to understand episodes of care and morbidities and risk behaviors associated with an agent, having a clear record of the trajectory of an agent is valuable. So this is an important step to it. It does have its trade-offs. This is voluminous information, and if we export it, we'll often want to export just a subset. But more than that, we want to be cautious about how much we record, because it is a fairly heavyweight operation. Let's just see something about this export. In order to export, you need to go to Export Settings. And it will ask you for an Excel file. And what I'm going to do is I'm going to go create an Excel file that lives in that same folder as the model. Now, you don't have to make it live in the same folder. You just need to have it live in a known place. So if you feel more comfortable, for this sake, of putting this Excel file on your desktop, that's great. But I'd ask you, if you want to follow along here, that you come up with a clear place where this is placed. So I'm going to go create an empty workbook, and I'm going to do a save as and place it in the same folder wherein lies the model. Okay. Okay, and I'm going to go put it there, and I'm going to say database output.xlsx. Okay, I'm just saving this file to a known place. It's empty. There's nothing in it. But ladies and gentlemen, soon there will be. And whence will that come? From the database, ladies and gentlemen, and from your own hand in enabling it. Okay, so I'd like you to put this out and put save, and there's our file. Now, very important step. Close this file after you created it. It's empty yet, but we need to close it so that the hand of AnyLogic can touch it. Okay. Okay. So what we need to do here, having closed that, is come back to AnyLogic and we need to select it. Okay. We need to go find that file, whither you put it, and go load it. Now, the AnyLogic mechanism for doing this is by my lights a bit confusing. So you do browse here. Maybe it already has prompted you, but in mine, here we browsed, we went and selected it, and it has the rather puzzling name save here. The point is it will overwrite this, and so it'll ask, do you want to overwrite it? And I'll say yeah. Maybe it's to communicate the fact that you're going to save to it, but you're not saving with the file as is. You're going to be writing to it. Okay. Now, having done that, you could select tables you want to export. One might be the messages table. Another might be the parameters table for those agents, say the city populations. Another's might be the state chart states, and perhaps we'll have a record of the events. Okay? The events which are occurring, which record a given agent in a certain city experienced an event. So I selected these without loss of generality, and you don't have to select the same ones. Those are just the ones I selected. You can say OK here. Okay. Now that configures it. Okay, and that's going to stay configured for a while. The thing that actually triggers, but by itself, it does not export it. To export it, you do this export tables to Excel. Actually crank and get it to actually write to that table. So there's a separate process for establishing the settings for output on the one hand, and actually performing the actual command to output it, which occurs here. You'll notice that you can elect to export these tables at the end of model execution, which would mean on a routine basis it could be exported. Okay? So having done that, ladies and gentlemen, I'm going to go back to Excel, and I'm going to inspect the fruits of my export. Okay, so here we are, database export, and lo and behold, ladies and gentlemen, here we see before us the fruits of our export. So here's the messages table. Reporting, who the recipient of each message was, and who the sender was, and the date of that message, etc. Here we go. Okay, and you could see it's a rather extensive table. It is somewhere around 13,000 entries. Agent parameters. These specify the parameters for different agents. You'll notice here we have parameters for main, which are indicative of the assumptions for this run, the experiment assumptions, that is the scenario assumptions. Those are encoded in main, right? Are they not? And then each city had a certain population size, which is recorded as well. Okay? The state charts here, each agent reaching state charts when they reached it. And then the events, which events occurred, etc. Okay, ladies and gentlemen. So here we have features of the model that we can output. It's quite voluminous. I would like to uncheck now, go back to database and uncheck log model execution. It's important that it's there. And I had thought, Kurt or Jeff, perhaps you could let me know. I had thought actually there was sort of a bio browser type interface now in AnyLogic where you can browse that information. Do you remember, Jeff, hearing anything about that? I thought someone had told me that now, but Didn't see it here, where you could browse the information for a given agent over time. Maybe that's still to be rolled out.
I haven't heard of it.
Yeah.
I think it's,
Okay. Okay.
they're just showing the slides
Mm. Got it. That it's coming. Yeah. Okay, ladies and gentlemen, so that's one aspect of output. Okay. I'd like to add another, whilst we're on that, like to add another one, and for this, I'd like to go to city. And remember we added this statistic, count infective? Remember that? Or prevalent case count? Remember that one? Not half an hour thence. Right? Okay. So here, I would like to add in to the city population a new type of construct called a data set. Now, data sets are a construct that has long been quite central in AnyLogic data recording and output. Because of some of this functionality of outputting directly from the database, they're perhaps not quite as central, but they're still very, very important. And so it's important to know about them. This will be called prevalent case count data set. I often like to suffix my names with the type, so when I see it, I know what sort of thing I'm dealing with. If I see it in a list with autocomplete, I know, oh, that's a data set. I don't want that one, or something like that. Okay, prevalent case count data set. Okay. Okay, ladies and gentlemen, with a data set, this basically stores pairs of values. Now, by default, the pairs often have their X, the domain, filled in automatically, the X element. And if it's in the main model, the X is the time by default at which something is recorded. If this data set lives in the experiment, the X is the iteration number. Iteration or realization number. I have to think about that for a moment. I think it's the iteration number.
Realization is the smallest.
Right, indeed. Indeed. Yeah. So.
The interval.
Yeah, exactly. So I think it's actually the iteration number. In any case, ladies and gentlemen, you notice this says use time as horizontal axis values, and we're going to use that. Okay. So we're going to be recording over time the prevalent case count in this city that obtains. Okay, so for the vertical axis value here, that's the thing we're going to fill in with the prevalent case count. How would we ask what is the prevalent case count right now? Where did we create that? Into what? City population. So we'd say this dot city population. Okay? This dot city population. That's what it is. And we're going to update the data automatically and have it update, ladies and gentlemen, every week. Every 1 week, we're going to have it updated. Okay? Are we okay with that?
Just this city population?
Oh, sorry. Sorry. Thank you. Prevalent case count. It would have been very unhappy if I had put that. What would have happened, you think of it, if I put that? Let's suppose I said this dot city population when I tried to build. Basically, it would say that's not a number. I can't put that in a data set. Watch this. I'll do it just to illustrate it. I would build it, and notice it says if one error, and it said cannot convert from city population to a double. meaning it can't render that into a number. So I put this prevalent case count. Notice that there needs to be begin paren, end paren at the end. I'll over and show it to you. There needs to be this at the end to show that you're calling it. Okay? You're actually calling, you're saying, hey, compute for me the prevalent case count. This is like calling sign, but it doesn't need any information to do its job, so it's begin paren, end paren. Okay? That's a statistic. Okay, so ladies and gentlemen, I'd like to run the model now, and I'd like to see what our hands have rendered. Okay? So we're going to run it we're going to run simulation, and this lives in cities, so we're going to have to burrow down to the level of city, and burrow we will. So we're going to be running this thing, and if we go down to the level of C here, of particular cities, that this prevalent case count data set is accumulating things. It's accumulating numbers of cases at different times. Okay, these times are 1 month apart. Now, you'll notice, however, a disconcerting fact that alert you to a common beginner mistake. This data set is maxed out at 100 samples. You've got too many samples for you to sort of handle. So one thing you got to be careful of with both graphs and data sets is be sure to leave it enough space to record, the full duration of time you're interested in. So in this case, I'll make it 10,000 samples that it stores, and we can run it, and we will then see for a given city, we'll see a record from the start time to finish of the incident case count. How did I do that? I went down to city, I went to prevalent case count data set, selected it, and then I selected the number of samples to record as 10,000. Okay? Okay. So, ladies and gentlemen, we're going to go run this, and this will record the number of samples there. Okay, so let's try this. And here, let's go down to level of city. And now we have samples for this city alone, for example. Each of them should be a month apart. Okay? And you notice there was one case early on, and then 0, and now we're starting to get kind of little outbreaks occurring. Here was a little outbreak, it died down. There was a little spike after it of 10, and now we're getting some sort of fluctuations around certain levels. So ladies and gentlemen, here's this data set recording it here, okay? Are we okay with that? Now, for those who have been in my boot camp in past years, you may remember that we had a little way of exporting these data sets from the model. Who needs help? Who needs TA help here? Okay? Now that involved writing, using something called an Excel file object, and we could point it to an Excel file, and it would write these out. But in this case, we have one for each city. We could do that, and the problem is there's going to be contention between the different cities. So we'll come back and show how that's done in a jiffy. But for now, I want to show you something very powerful about this feature of AnyLogic using databases, okay? Which will make this job much easier. Ladies and gentlemen, I would like to go back to our friend the database. Okay, now this database here, you recall that it has an option, log model execution. We're going to log it. Okay, log we will. But we're going to go to export settings again, And we're going to go down and log data sets this time. Do you see that? There's data sets log. We're not going to change the file to which we're exporting, but we're going to choose to export data sets. Do you see that as an option? How did I get that? Wherein did I go? I went to the database. I said log model execution, which we actually didn't strictly need to do quite yet, but I did export settings after that, and I chose datasets log. Do you see that? Okay, now, ladies and gentlemen, we're going to do the following. We're going to run this model, okay? Now, the model will run a lot slower because it's been instrumented to trace these things. So we'll run the simulation, and we're going to go and see it after it runs. We'll run it for a little bit. We'll run it for months at least. You'll notice it takes a little bit longer to start running. Okay, I'm going to run it full blast. Open, and I'm going to run it for a bit. Now, whilst this is running, it's writing to the database. It's writing to the database this record of events and agent transitions between state charts and quite a bit of information. But more than that, ladies and gentlemen, you recall down here in the data set, we're recording this information. Remember that? This data set we just added? So ladies and gentlemen, let's stop the model now. As long as it's run out for more than a year, say stop it. Are we ready? Let's stop it and let's close the model. Notice when it closes, I think it's going to take a little bit more time because it's writing to the database as well, or doing database related things. Okay, ladies and gentlemen. Thanks, so. Who needs TA help? Okay? Okay, ladies and gentlemen, now let's go down and go to database, and let's go to the log and double click this time on the datasets log. Here's the datasets log. This is recording for each city. You'll notice this is city 0 here. And we have an X and Y location. Don't be fooled by X and Y. That's not their location. X and Y are the values in the data set. So X here is the what? You notice these are equally spaced apart. This is the time. And Y is the number of incident cases recorded. Okay? So this is the first city. Here's the second city. See over here? Here's the end of the first city. You can see it's quiet early on. First city, and now it's transitioned to the second city, ladies and gentlemen. And now over here on the right-hand side, we have the second city, and now it's transitioning to the third city and the fourth city. Each of them has a kind of epi curve recorded in terms of number of cases over time on a monthly basis. That's what that is. Now,
Can I ask a question?
Can.
You know, the model is having a time step of 1 year. And so I'm not really understanding what the time
No, the model does not have a time step. The model is a time unit of 1 year.
oh,
That's a totally different thing. Remember, time is continuous in AnyLogic. So just because we use a yardstick of years to sort of quantify what point 1 means or what 3.2 means, the actual model is executing as finely as it needs to handle the requests in this model. If there's a very high mortality rate at certain times, if there's high contact rates, maybe mortality is low, so there's long time between mortality, but there's there's very rapid context going on, like several times a day, it's going to be simulating as fast as it needs to broker those things. And the things that are going on will go on at their natural time. So, maybe I'll have a bunch of contacts and then I die, and those go on at their natural times. This is not, and that's in contrast to NetLogo, for example, or traditionally Repast and so on, where it actually jumps from one point to the next, and it has to figure out, say, on a per year basis, it goes next year, and then it has to figure out everything that went on the past year, which came first. This person died before they graduated, or vice versa, were they diagnosed before they died. It has to sort of figure out the natural ordering of things to avoid artifacts and avoid sort of weird things happening. And sometimes in agent-based modeling literature, you'll see sort of a lot of discussion about this issue of the model results were very particular to the particular order with which we handled things at the end of the year. That doesn't go on here at all because we're using continuous time. Time occurs as fast or the events of time advances as slowly or as fast as possible. If there's a lot going on right now, it'll advance in very small little increments to handle every little event at its natural time. By contrast, if it's in a period of stasis, it may jump forward in a slow way. So these times here are occurring within a year. You're absolutely right. But the time step is not a year. This model is actually, in fact, if we view the model as it runs, here you'll actually see that it's running within a year. And I'm going to, before I do this, I'm just going to say export tables. Make sure that Excel is closed. Close your file in Excel. And then, once it's closed, do export tables to Excel. And I'll show this issue of kind of model execution because it's an extremely important point. The difference in a model time unit and a time step. And in something like NetLogo, they're the same. You choose your time unit, often a tick is a year. And so you're talking about years in terms of ticks. 2 means 2 years, and it's the granularity of the time step too. Far from that here, and I think we're the better for it, richer for it, because continuous time just eliminates a lot of worries of sort of unnatural features. Okay, I just exported that. I will yes, Kurt.
Think about that?
Yeah, absolutely.
Maybe one way to think about it is kind of that time step. There is a time step, but it's dynamic. It ages.
Yeah.
So it's a bit like the computer says, every agent basically has a list of when some behavior is going to happen. So this guy's like, okay, I know that I'm going to graduate in 2 years. This guy's like, I know I'm going to graduate in 3 years. This guy says, I know I'm going to graduate in 4 years. The computer goes, well, I have nothing to do for 2 years, so let's just jump there.
Right.
And then it jumps there. It calculates as if it had sort of been running through what all the values should be. And then the person graduates, and so there's a time step, but the time step is associated. The agents control the time step as they go through the step.
Yeah, it's not a static time step. Basically, the next thing to be done is so-called dynamically scheduled.
Yeah.
So if I send you a message, that has to be handled immediately, and so that you'll have to handle it immediately. By contrast, there may be long periods where there's no one in a population, there's no infection going on, and there's only the occasional reporting process going on. And then there's a flurry of activity, and it needs to be simulated several times a day. And so it's brokering all of this on a dynamic basis.
So I had a follow-up question in
Yeah.
regards to that. If you have real data that you're trying to import in,
Yeah.
how would, like for like calibration,
Mhm.
how could somebody put X if they don't know what X is going to be in the model? Like if I know that at time 1 and
Yeah.
at 3 there are like X number of pieces.
Yep.
And if I import that in,
Sure.
what would 1 mean? Like 1 would mean the first week, but in the computer it could mean something else. Like,
No, you could set it to be the first.
That's what the time unit comes
So you'd say this occurs, like, if your time unit is weeks, that would occur at time 1. If your time, if your time unit is years, it would occur at time 1 divided by 52.0. And so that would be the time at which it would be matching that data in the calibration process.
Okay, so we will know ahead of time, like,
Well,
Yeah.
you'd have to know that the number you're putting in is, you need to know the unit, and then you basically need to tell the computer
what unit
the number
it
and
is.
what the unit is.
Okay, and then it does.
Yeah.
Yep.
And then it has
Yep.
that.
And it can handle, to its credit, it can handle, you know, it knows what a week is and what a day is and what a year is and that sort of stuff. And in fact, it has actually a quite sophisticated calendaring system, which actually can take into account leap years and all that sort of stuff if you wish to use it. But the key point is that when you're specifying data that has times associated with it, relative times, you will need to characterize those times, often in a natural time unit that you find convenient, to AnyLogic, so it can appropriately match them. If that's what you're asking, sort of like in calibration, it's trying to match at week 1, week 2, in month 3, you know, day 45, it can match the appropriate data from the model. Because remember, in the model, we could tell it report every week, or we could tell it report every day, or we could tell it report every year. We could tell it to report all, you know, across those different types of information, just like we could in a real-world system. And so you're going to be wanting to sort of compare comparable times in the model with comparable times in your data.
Yeah, and so if you have data that lasts for more than a year and
Yep.
the data you have is in days, after the first year, you still keep adding on, right? You don't start.
Yep.
Okay.
Yeah, that's right. I mean, you could treat it all, you might want to specify it as days 735, day, you know, 320, what have you.
Okay.
Is that helpful?
Yes.
Yeah, okay. Ladies and gentlemen, so I just opened this file and I went to datasets log, and you'll notice here that in datasets log, there's a log of the data associated, say, with each city. Here's a log this is the record of what we got in that data set, which was recording prevalent case count. So all of these down here are for cities 0. You'll notice that for different, we've gone to cities 1 now. Here we go. And this is the time here. This is the time in years. We had it report every 1 month, but the time unit of the model is years. So 2.12 means 2.12 years.
I thought it was every week.
Oh, well, okay. So maybe it was every week it was reporting. That probably makes more sense. Let's go check. So we went to city, and we had within a city here. Okay, within a city we had the data set, and within the data set we told it to report every week. Yes, it was every week. So it's recording every week, and this was 2.12 years. You know, that it was the last one for mine, but for yours it probably went different lengths. Yeah.
And Nate, so is it the number that happened over the course of the week? So like if you're counting how many are in a state, some you could go in a state.
Okay, so this is prevalent case count I've reported. I've reported the number who are infective at that time as a snapshot. Now, I was hoping to get to exactly what you're asking, which is the incident case count. The incident case count over the course of that week, how many got infected, or how many became infective, emerged from latency. And we can certainly do that, and I will try to make that happen within the confines of time.
But that's not what this is. This is definitely prevalent. It's at the time when the week comes on Sunday, here's how many there are.
Right, and you could see here, this is going off weekly, and it's just asking, to understand the semantics, we have to ask, well, how does it compute it? It computes it by calling prevalent case count, in the population. And in the case count of the population, we have a statistic prevalent case count that simply counts up the number in that infective state at the time. Remember, ladies and gentlemen, this is an extremely important point when it comes to data output, when it comes to reporting from the model. Statistics are great, but statistics have tight limitations, and we've been talking with AnyLogic about getting them to help us put more mechanisms in the model for a broader set of a broader support for statistics of meaning-ology, like incident case counts, and like breakdown stratifications by different things, etc. But what is it? What I'm saying is a big constraint with statistics. There's a big constraint, and that is this is a statistic as computed, nicely declaratively, but over a population at a certain time. Full stop. So it's computed at this snapshot of time. This is what it is. It does not support easy specification for what I call flow statistics, like the number of people getting sick over the past week. For that, we can do it sweetly, but it takes a little bit of mechanism, and I will show that to you before the day is done, before the cows come home. Okay, ladies and gentlemen, let's do plus here, and I want to show you a trick just because people often worry about how to do this, and it's a nice little trick. I'm going to say prevalence. I'm going to say fractional prevalence. Some of you might call it prevalence rate, but I prefer to avoid that term because it's not a rate. It's not a thing per unit time. More rate than an exchange rate is a rate. It's a ratio. Okay, it's not a thing per unit time like the interest rate or the incidence rate. It's a ratio. It's a fraction of population. So this is what we do. If, in case you want to have a nice, easy way to do a fractional prevalence, it's quite easy. Ladies and gentlemen, what you can do is take the average over the population of this thing. You basically ask, is it infective? If so, it's 1.0, otherwise 0. Okay? If you take the average of this over the population, imagine you have a population of 100, and you have 10 people who are infective and 90 who are not. If you take the average of this, you have for each of those 10 people who are infective of 1, and the others it's all 0. What the average of that is going to be is actually 0.1, right? Because 10% of the population is 1, the rest are 0. So you're going to have an average of 1. This, ladies and gentlemen, if you take the average of this expression, this is going to give you the fractional prevalence. It's the easiest way to do it in AnyLogic. You can do it other ways. You can count up and be dividing by the number of people in the population, so on. But this actually is very efficient, and it's fairly straightforward, and it doesn't require any external mechanism.
Could you just repeat or
Sure.
recap like what that logic is saying?
Okay, the logic is this. Suppose we have, so great, I welcome that question. Ladies and gentlemen, suppose we have, let's think about 10 people, okay? There's 10 people in a population. One of them is infected, and so one person's infected, and the others are uninfected. So here we have them. So here are the first 5, 6, 7, 8, 9, 10. Here are these 10 people, right? Now, what this is saying is, we're going to average and this is the average over something. Over what is an average? First of all, it's over an average over the whole population. That's why condition is empty here. And for each person in the population, who's going to be called item in turn, we're going to ask, are they infected? Gotta be careful with this pen here. If they are infective, we're going to treat it as the value for them as 1. Otherwise, we're going to treat it the value as 0. So here's these 10 people. These guys are all assigned the value 0, right? Just to make it clear, it's a 0. This one's assigned the value 1. If we take the average of this, we are going to see that the average, it averages out to 0.1, because we have just one that's 1, all the others are 0. And that's the prevalence in this population. Because you could think of it this way. Average is already, it's like totaling up and dividing by the total size, the total number of things you're totaling up. So the average of these is like totaling them up, which is going to yield the number of people infected. Right? And by totaling them up, if every infected has a label 1, and we total up, and all the others 0, we total up, just like that, we're going to be getting out the number of infectives, right? The count of infectives, because all the infectives are 1, everyone else is 0. And we're totaling up and we're dividing by the number, right? That's what an average is. It totals up and divides by the total, by the number of items. And so this is totaling up and divided by the number of items, which is the denominator we want for a fractional prevalence. So this yields the fractional prevalence. We're just summing up 1 for each person is infected, 0 for the others, and dividing by the total number. That's what the average does. Is that helpful?
Yeah, and so then by leaving condition blank, it will automatically do it for the whole population.
Yeah, condition, if you don't fill it in, it just does it for the whole population.
Thank you.
Is that okay?
Can AnyLogic do math on Booleans like an R? If you thought of those as true falses, you could take the mean of the vector and it would be that. You could
Yeah,
It
it doesn't do that.
It
Now,
doesn't think about that.
there's some really, man, we could do some pretty neat nerding together if you were interested. I'm a big R user too, and so I could show you some really nice stuff with Java 8 that you can do in AnyLogic. And in some of my flights of fancy and some of my boot camps, I have done that, and it's beautiful. It's just utterly beautiful, and it has a little bit of that flavor because you can take things, you can map them, and map them several times and reduce them, and it has kind of a R-ish kind of flavor to it, and that's all good stuff. But time is a fleeting, and I don't have time here to show that. But yeah, there's a little bit with Java 8. And it's in some ways it's sweeter than R in some things, and so anyway, yeah, we could sit down and have a good time showing that. Okay.
Sounds like a good Friday night.
Yeah.
My idea of a good night.
Yeah. Okay, so ladies and gentlemen.
I think there's another question.
Oh, was there another question?
No, I just was wondering, isn't that a command?
No. This thing here?
So it doesn't need a colon?
Nope. It's because it's just determining a value. If this person is infective, their value is 1. Otherwise, their value is 0. Remember that this question mark colon, that's actually a sort of an if-else expression, kind of like you have in R, incidentally. If-else. So if this is true, then their value is 1, otherwise 0. This is just determining for each person in the population called item what value to use for them. And if they're infective, it's going to use the value 1, otherwise 0, and it's going to be taking the average over each person. Does that make sense?
Yeah.
Yeah. Okay. So ladies and gentlemen, So this is good. This is the fractional prevalence, and we've seen in our sort of tool over here how we can export these data sets quite readily. Okay, let's keep on going at this. I want to show you some input too. Okay, I'd like to show you some data input. So we're going to take this model in a different direction. I'd like you to stay in city. Okay, I'd like you to stay in the city, and I'd like you to humor me with something. I'd like you to go to the palette, and I'd like to add into city something you probably don't expect. Name. Ladies and gentlemen, name. And guess what sort of type this will be? Will it be a Boolean, an int, a double, a date, or a string? It'll be a string of characters, a sequence of characters. And we'll leave its default value blank. Okay? Are we okay with that? Okay. Great. String. Okay, ladies and gentlemen, now we're going to go to projects. And we're going to go to the database, and we're going to unlog model execution. We don't want to log model execution any longer because it will bog us down a little bit. So we're going to the database and we're unchecking execution. Okay. Now, would one of the TAs mind getting me a bit of water? Here's a bottle. Use this one. Thank you.
2 teams can do it.
Okay. Thank you. I'm sorry for the trouble. Okay, ladies and gentlemen. So we unchecked log model execution. Cold is fine. Thank you so much. Okay. So this is what we're going to do. We are going to go to the database, and we are going to use a totally different thing here. Create or import a table. Do you see that? When you've selected the database, we unchecked log model execution. We're going to say create or import a table. Are we good? Good or not?
Good.
Okay. Now here we're going to, you notice this is a thing of import. I'm sorry for the trouble. Thank you so much. Oh, just, yeah. That's great. Thanks. That will sustain me. Grateful. Thank you, Norges. Thank you, Hal. Okay. Okay, ladies and gentlemen. You'll notice we can import a database table here. If we have database externally, we could actually import it. Bring data into our project from a database. So if you have an SQL database, or like an Access database, or MySQL, or Postgres, or DB2, or Oracle, what have you, can bring it in. Alternatively, ladies and gentlemen, you can create an empty database, and that's what we're going to do. So I just said create an empty database. Did you see that? Okay. Okay, great. So we created an empty database here. Now, this empty database has a bit of information provided by default, and we're going to change this. For the name, we're going to change it to DB cities. Notice if we had a database of cities, we could import it. Okay? Are we okay with that? DB cities. And then for the column name, ladies and gentlemen, for the first, it's proposing a first column. I'd like to make this city underbar name. And guess what its type is going to be? A string, indeed. String. Okay? DB city name. Now, we can plus here, and it will propose to us another column. And this one, we're going to make DB population size. probably should have called it just name, but that's fine. DB population size. What sort of data type do you think this will be? An integer indeed, ladies and gentlemen. Next. We're going to specify here DB. We're going to say DB location underbar X. Now this could be, I was converting this model to a GIS model, and I could show some features, but this one's going to be the X location, kind of in an abstract space, and it's going to be a double. And next we're going to have a Y, DB location Y. Okay. Now notice there's some extra information. One is if it's indexed, so that can allow it to be looked up more quickly. Another one is if it's unique. Can it have repeat values? Okay? Are we feeling okay with that? Okay. So here we've defined, let's go through this again. DB cities, DB underbar city underbar name, DB population, so DB underbar city underbar name is a string. Make sure everyone gets that, a string. Do you see that? It's going to be a name. It's going to be a sequence of characters, a string of characters. DB population size is an int. DB location X is a double. DB location Y is a double. Okay? Great. And you notice there's some things about optimizing performance, whether you're going to expect to handle lots of data and etc. Okay. There's a lot more we could put in here, including foreign key information, like this is an item which relates to an entry in another table. That would be where foreign keys start to come in. We're not going to get into that right now. This is going to be a kind of standalone table. Okay, ladies and gentlemen, so we can click outside. That's great. And now we could start to put in some information here. Okay, we have, you notice over here on the left-hand side, we have DB cities. Okay, and we are going to fill in some information, and this is going to just fill in some placeholder information so that you can see how this is used. Okay, so ladies and gentlemen, I'm most pleased, as in my role as your host, to enjoy the pleasure of acquainting you with some of the geography of our fair province. First city will be Saskatoon, and the city population size, we're going to say 1,000, okay? And its X location will be 200, and ladies and gentlemen, its Y location will be 200 as well. Okay? So Saskatoon, population size 1,000, DB location X is 200, DB location Y is 200. Next city is Regina. And in deference to the Queen City, we'll also make its population the same size. It's a beautiful city if you have never visited it. And its X location is 250, and its Y location will be 400. It's further south, and as we go down in Y, we're increasing that. Okay? And it's kind of a little bit more to the east of Saskatoon, further south. Okay, next will be Prince Albert, the gateway to the north. It's going to be a smaller population size, but one that's rapidly increasing with 500 here. And the city location X is going to be 250. It's also a bit to the east of Saskatoon, and its city location Y is 100. It does not Prince Alberta. Prince Albert. Okay, Prince Albert. Okay. Very nice city with the North Saskatchewan river running through it, very close to the forks of the two Saskatchewan rivers where they powerfully come together, and quite nice area. You see the signs of the boreal forest all around. Moose Jaw, ladies and gentlemen, a city with a notable name. Size 250, and it's going to be X location 180 and Y location, ladies and gentlemen, 400 as well. It's a close neighbor, a fairly close neighbor of Regina. How long does it take to drive from Regina to Moose Jaw? 45 minutes? Okay. Estevan, a city near the U.S. border. They say it's the sunniest city in Canada. It's a city population size of 100, and city location X is 450. City location Y is 500. Estevan, the birthplace of someone who, for many years, including during some of my time at MIT, was the head of my department, Department of Computer Science, Eric Crimson. You can look it up. Next, Swift Current, a city not so far from the stunning landscape around Cypress Hills. Population size 100, and location X 100, and location Y 400. Okay, those are our cities, and you don't have to sweat the details. The point is that we have a set of information in a structured form, in a tabular form, which includes some names, some information that will relate to parameters and relating to locations X and Y. This could be latitude, longitude, and for coordinates, right? Okay, in a GIS model. Okay, ladies and gentlemen, we're done with that data entry and with your geography lesson. Okay. I'd like now to acquaint you with how we can use this to import data into AnyLogic. So, I would like you first to go to Maine, ladies and gentlemen. Not Maine as in the northern state of the U.S., but Maine as in the class. Okay? Okay, and in Maine, ladies and gentlemen, I'd like to go to the population of cities. Okay. Actually, even before I do this, yeah, okay, we'll do it. Cities, that's fine. So we're going to go to cities, and you'll notice that if we look more carefully at these properties of these cities, do you see there's something that says initially empty, contains a given number of agents, that's what we have now, or loaded from a database? Do you see that? So we're going to choose loaded from a database. Okay? And where it says table, you may be fooled because it's initially blank, but you're going to go and pick DB cities. Okay? DB cities. Are we okay with that? Now, that doesn't occur automatically. We have to tell it, okay, we want to import this from a database table. Great. We tell it which table. Now it needs to know, well, okay, the items in the database table have particular pieces of information, like name or like population size. How does that relate to what the information the cities need to be instantiated, to be created? You see what I mean? How does that relate to them? So this is what we need to state. It's called agent parameter mapping. Do you see that? This area here? So it may sound daunting, but it's not going to be bad. Are we ready for this? Okay, ladies and gentlemen, for the first parameter, let's choose name. Whence did these parameters come? Do you recognize these? Whose hand created them? Your own hand. You created these names. Remember name you created not so long ago, population size, yesterday, when you built this model? Remember that? Okay, so we're going to say name. For the column, we're going to choose DB city name. That's how we're going to get that information for the name from that column of this database. Does that make sense? Next, for population size in the model for a city, guess what column we're going to use? DB population size, ladies and gentlemen. Ladies and gentlemen. Now notice it lets us set the GIS location name, latitude and longitude, but we're going to choose location X because we haven't converted this to a GIS model. That wouldn't be hard to do, but I haven't done it here. If we had another half hour, we could probably do it. Okay, location X here, ladies and gentlemen. What do you think that's going to what do you think that will map? Will that map? DB location X. Same thing with Y to the corresponding mutatis mutandis to the DB location Y. Okay? Okay. Ladies and gentlemen. Okay, we're close to done. Okay? So, ladies and gentlemen, if you scroll down, there's nothing more of great concern here. You notice that it's actually changed where it says parameters. See that? See this here now? It actually says these parameter values will be used for dynamically created agents. In other words, ladies and gentlemen, for the initial set of agents, whence will they come? They will come from loading this database table. Later agents will be lent form by these parameter values here. Okay, that's and so it's telling you these ones will be used for later ones, right? These ones will be used to kind of fill in the gaps for later ones. Okay, ladies and gentlemen, we're almost done, but there's one thing that still we have to confront. If we go back to main, if we go down main, and we select main as a whole, so you see its properties laid bare before you on the right-hand side. Do you see that? I would like to go and scroll down to where it says space and network. Do you see that? Space and network. This is, so again, we're selecting main. We're going in properties. It should say main agent type. Scroll down to space and network. Do you see that? And I'd like you to change layout type to no longer be random. Choose user defined. Because you don't want it to kind of throw away the X locations from that table and say, I'm going to make them random. You just want it to use the ones from the table. So rather than having space and network say layout type random, you just have it say whatever the user wants. Don't override it. Does that make sense? Ladies and gentlemen, let's run this. Let's run this. It's time for you to enjoy the fruits of your labor. Okay? Run. So here we go. It's building. Should be a happy camper. And I'd like to now that actually loading from that database. And there is, ladies and gentlemen, is a stylized form, a depiction. Okay, Swift current looks a little too close. We should current further displaced. But here's Regina, here's Moose Jaw, here's Estevan, here's Saskatoon, Prince Albert. And unfortunately, you better watch out outside the window because there's an outbreak going on. And these cities are connected, and indeed there's a thoroughfare there, 45 minutes, as Liam said, from Regina to Moose Jaw. And here you have multiple routes down to Estevan, which is in fact true. Okay, ladies and gentlemen, so here we've loaded this model, but don't take my word for it. Let's go down to the level of a city. Okay, here's city, and what fair name is borne by this city? Saskatoon. Let's go up to the next one. Here's the Queen City. Recommended by Wascana Lake, a beautiful legislative building, a science museum, governor's house, a whole bunch of other neat places, the University of Regina. The next, Prince Albert here, and next Moose Jaw and Estevan and Swift Current. Okay, and you'll notice that they have the corresponding population size that we assigned them. Okay, ladies and gentlemen, we've just imported data from a little table that we created. But wait a minute, how would I get that data into the model? I don't want to have to retype it. Well, remember I said you could import a table here? You could import a table into this database here. So this table here, we could see it says import database tables. If you right click on that particular table, do you see that? Import database tables. If you right click on it, now check this out. We can connect to an Excel file, for example, browse for that Excel file, and select the tables that we want to import, and we could import update data on model startup if we want to as well. Okay, so this provides a way to draw data from sources. Now that's not the only way, ladies and gentlemen, and in fact from this very seat a year ago, I led it in a session over in S311. I help students learn about some additional ways that I'll quickly show you. But I want to get to the question that was raised by Michael, because it's a very important question. It's a very practical question on how we compute some flow statistics, these statistics over time, where AnyLogic is not going to provide the base mechanism, the mechanisms out of the box. How do you do that? I'd like to show you, but you should be aware, meanwhile, that in the connectivity palette, there's a set of tools, and you'll find videos of me expounding the use of these tools online, where for example, we use an Excel file to import data from the rows and columns of an Excel file that's specified. We can also use it to export. And I'm not going to ask you to do this, but I will drag in an Excel file here, and I will simply let you know, okay, so this is interesting. It's, I can go specify an Excel file. I'm going to close this one, and I can actually point it, for example, to the very one I created before. Okay, and I could do this, and I could point it to that, and here I could say, does it load on the model startup? Is it saved away a model termination? And I can do things like read and write to it, to particular cells in it, cells on sheets, particular sheets in this file. And in fact, in an Excel file, we can write whole data sets to it quite easily. Just say, write out this data set to this file. So it's also fairly powerful. In some of my exercises, I have further, ladies and gentlemen, when we have wished to specify a population, like the for a population of people or of cities, when we've needed to, the more compelling case is for experiments. I've actually shown in my videos, how do you read from the Excel file particular values. So I might do something like this. I dragged in that Excel file, I pointed it to a location, I might add an experiment where I say, you know, Excel directed experiment. Excel directed in the sense that it's drawing its data from Excel. And so here, you know, maybe for the migration rate, I draw it from the Excel file, something along those lines. In which case, if I wanted to do that, then this Excel file would need to live in the experiment instead. So I'll pick that up from main. I'll take it out of main, and I'll put it in the experiment. Here we put it in the experiment. There we go. And now for the experiment, I might ask, for example, Excel file dot, and you can see when I have an Excel file like this, I could go ask, get a value, for example, get a Boolean value or get a numeric value. And if I were to ask get a numeric value, I could get a numeric value from a certain sheet, a certain row and column index. So in short, when I run this model, it could bring in the parameter values to use from a certain location in a spreadsheet. Okay? That's one of the advantages of having such a thing as an Excel file. Okay? So I can actually use this in quite flexible ways. Alternatively, I could use it while the model's executing. You can see also, though, you can write data sets directly to Excel files. And that would allow that data to be output to the Excel file. But time is short, ladies and gentlemen. And I want to break in 15 minutes. So before we do this, or before we dive in too much detail into that, I want to get to Michael's question, because it's a very important one. Okay, so ladies and gentlemen, this is what we're going to do. We are going to compute across the entire model, this entire model, the number of individuals who are emerging from latency to an effective state each week. Okay. Remember that this might be something we can actually measure in the world, or it might be a quantity we use for understanding model dynamics, even though we can't perfectly measure it in the world. Imagine a TB model where we record the number of people getting infected with TB, and entering a latent state. We can't typically observe that directly in the world, but we might be interested in model dynamics. So just because something's not directly observable in the world doesn't mean you shouldn't collect it from the model. It may be important for developing insight as to what's going on in the model, the dynamics. Ladies and gentlemen, therefore, let's go here. Let's go to main. And I would like to put into main a reporting event. Okay, into main, I'm going to put in a reporting event. Okay? This is going to be report incident, report weekly incident case count. That's going to be the name of it. Okay. Now, what sort of event do you think this will be? Sorry? A weekly event. So it'll be a timeout event. And what sort of timeout event? It'll be a cyclic event. Cyclic or cyclic, yeah. It's a cyclic event, and it will go off every what? 1 week. Are you okay with that?
You don't need to change the first occurrence time?
Well, I'm keeping the first occurrence. It's a good question. It depends. Do you want your first reporting to occur at time 0?
I'm
It's
sorry.
automatically going to be 0.
Like, because I grabbed that 2 weeks too at first and without.
Oh.
Does it matter that that says 0 years?
No, because 0 years is going to be the same as 0 weeks. But you may elect to have the first reporting event occur at time 1 week. I mean, that wouldn't be a bad thing, because it's, after all, the way you'll see it, it's not going to be picking up anything before that. So we could say it starts at 1 week and then its recurrence time is 1 week, right? You notice once again, it's this little reminder. We can log it to the database, etc. It's good stuff there. Okay, ladies and gentlemen. Now the question is what the action is going to be. And I'm going to ask you to reason through this with me, okay? Quite a few students have, not from computer science background, have struggled with this. So we're going to imagine a situation where once a week we report. This is very common that we're going to have a set of processes in our model that are what might be called observer processes. They're epiphenomenal. They collect information in the model, but they don't affect the governing factors in the model. They don't change model operation. Rather, they observe the model. And this is going to be one of them. Now, how would I keep track of the number of people getting, becoming infective each week here? Well, ladies and gentlemen, you could imagine a situation where I have an arrangement where someone calls me up from, the ER every week. When someone comes in with a severe case, they call me up and say one more. And I'm just tallying things up, right? Over the course of the week, I have a little tally, and I'm tallying up. And at the end of that week, at the end of that, 5, I go and okay, I've got 3 more. And then the end of the week comes, and I say, okay, I have 8, right? I record that. Maybe I put it into my ledger or what have you. And then I'm going to start again for the next week. For the next week, I clear the slate, and I'm going to start again, right? Maybe the next week 3 come in before the week is done. And I clear it again, and now, the next week another 4 come in, and I clear it. The point is, after each week I clear it, okay? So we're going to have the analog to that. Maybe I should say we're going to have the digital to that. Okay, ladies and gentlemen, it's analog with a GUE at the end, not with a plain G, yeah. Okay, ladies and gentlemen, we are going to have our ledger, it's going to be in the form of a variable, okay? And this is going to be called something like running count of incident cases for a week. The point of running count is that it's a count to this point for this week, okay? Just like I'm kind of putting these things down as new cases come in. I've got 2 so far. This is my running count, okay? Now, what sort of thing is it going to be? If it's a count, it's a what? It's an integer. Yeah, it's enumerating thing in a discrete fashion. And its initial value will be 0. Okay? We're going to start with it blank. None. Okay? Now, the question is, we're going to be recording the number of cases who become infective over the course of the week. So how do we know when a case becomes infective in this model? Whither do we go? Yeah, the state chart. So let's go to person. Kate's got it exactly. Here we are in the state chart. We're going to be looking when someone becomes infective, okay? Now, there's an interesting question here, and it could take a little debating. Do we count the people who start infected as incident cases? And I'm going to make, the bus the bus is coming and a rush will soon arrive, and go scan for the bus. Okay? Okay, keep an eye out. I'm watching out for them. Okay, so where might we record sort of a new incident case? I'm going to say it's in this completing latency, okay? If we complete latency, we'll count that as an incident case. Someone's becoming infective, and maybe we'll grant that the latent time and the incubation time is the same. They're actually becoming symptomatic, okay? So
Also have an exit action from exposed.
yes, you could. Yeah, that's a good point. That's a good point. It's a little bit of well, you could put it reasonably. There's a reasonable argument for it in three different places here. The entry action to infective, along this, the action associated with this transition, or the exit action for exposed. Each of them, I could imagine someone arguing, some reasons for that. I'm going to happen to put it in this completing latency. So, ladies and gentlemen, what do we want to happen when someone, becomes symptomatic? They pick up the call and they call me, and what do I want to do to that variable in main? Yeah, incremented by 1. Maybe it's 1 right now, and I want to make it 2. Right? Maybe it's 2 right now, and I want to make it 3. So I need to increment that, ladies and gentlemen. So we're going to say, where does that variable live? Wherein does it live? Main dot running count of incident cases per week. Now, we could write, ladies and gentlemen, we could write this equals this plus 1. But the people who have been in my Java tutorials know a briefer, more succinct, less wordy way to write that. What is it? Plus plus. Particularly when it's sort of this long, ungainly thing. It enjoys a measure of beauty to recommend it. Do you agree, Kurt?
A measure, yes.
Yeah. Oh.
It's still long and ungainly. Its girth is near the size of its box.
Yeah. Well spoken. Yeah. Okay. So.
I do not go easy into that good night, dear sir.
Okay. So we increase it by 1. Okay. So that's a great start. Now let's go up to main. We're almost finished, actually. What do we do here? Remember, once a week, we report what our case was, and then what do? We clear the slate. We clear the slate, ladies and gentlemen. So here we're going to report out number of incident cases. Now, how are we going to do that? Well, there's going to be 2 mechanisms, but I would like you to humor me with one thing. As Jeff might say, win one for the Gipper, okay? I'd like to go to the analysis palette, okay? And I'd like to drag in a data set, okay? This data set is going to be the data set incident case counts for case count for week. It's going to be incident case count for week data set. Incident case count for week data set. Is that too ungainly for you, Kurt? It's the Twitter generation. And, right. Okay, incident case count for data set. Although Kurt is admirably well read, and his reading extends admirably far beyond Twitter messages.
I don't know. I don't have a Twitter account.
Okay. Well, I admire your taste. Okay, incident case count for week data set, ladies and gentlemen. We're going to retain this. We'll say keep up to 10,000 latest samples for this data set, and we will here not update the data automatically, okay? 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 We'll not update the data automatically. So we're just about done here. We've added this data set. All I did is change it to 10,000 samples. We're going to be recording values, and each of them is going to be time-stamped because we're using time as the horizontal value. Okay, next, repeat weekly case count, report weekly case count. All we're going to do is the following, ladies and gentlemen. We're going to do incident case count for week data set. And we're going to say dot add dot add running, so this dot running, really we should say this dot incident case count and this dot running count of incident cases per week. Okay? Okay. Okay. And then we'll print it out. We'll actually use trace ln and we'll say incident case count for time. These are double quotes around this, plus, and I'm going to say time, begin paren, end paren. Now, quote again, is, colon, plus, and then this running count. Okay? I'll put this up in the big screen. And then finally, what do we have to do with that count? We have to set it to 0. So I'll put this up on the big screen. Okay? Okay. Okay, there we go. Ladies and gentlemen, Kurt is absolutely bang on as normal. The wordiness is sometimes excessive.
Thank goodness for control space.
Yes. Control space is your friend. Okay? Okay, ladies and gentlemen, so this is incident case counts for week. Okay? So this is, I'll just put the separate lines. So we added the value in to the data set, we printed it out, and we set it to 0 for the next week. We clear the slate for the next week. Does that make sense? Ladies and gentlemen? Does that make sense? Okay, so let's, should we go run it? Should we run it? Okay, so let's run this now. Okay, and we're going to run here, and Arash, could you keep your eye out for the van? Okay, thank you. It is?
Yeah.
Okay. Okay. Ladies and gentlemen, here's our data set. Keeps track of our incident case count across the whole model. So I'm running this here, and as it starts, what you should see is the values in it. Start values of it are recording. Here's the case count for that week. Okay. There we are. Okay. You notice it's not monotonic. It rises and changes a little bit. And you'll notice you can also create this little graph here. Do you see that? That also will graph that out over time and knows how to graph it for a data set. Okay? These data sets, more than this, and I'll let you go after making this point. If you go to this data set, you can actually right-click on this and say copy. And then you can go to Excel, to a sheet of your choosing, and you can paste in and get a copy of that data set as well. Okay? I would note that the same thing is true for graphs. You can right-click on the graph and say copy, or you can say copy image. If you say copy, it copies the data that's gone into the graph. Same thing with histograms. Same thing with 2D histograms, which you'll see tomorrow. Okay, so that's all for now. The bus waits.
Can you show the code again?
Sure, I'll upload that post haste. Sir, I'll look at that code. Here we go, right there. So all I did is I said dot add this variable, okay, and then I printed it out, and the value out, and then I zeroed it out. Okay, and I will as soon as people are done looking at this, I'll upload the model. Yep. Do you want that up there longer? Anyone want it up there longer? If not, I'll post it. So input, output, good. Okay, so I'll go post it, and it is about to make its way. Okay, we don't want to do that. Okay, okay, we want to go to models, models, and we want to do input output, and here we go. There we go. Okay. Oops, I should have saved it first. Okay. There we go, and I'm going to remove that, remove, and we will do new upload, and ladies and gentlemen, the model is there. Okay, thank you very much, and I'll look forward to seeing you tomorrow morning. We're going to have presentations by Kurt tomorrow on sensitivity analysis and calibration, if that's good with him.
When?
Tomorrow morning,
Sure.
first thing,
9 o'clock.
if that's okay.
Sure. I think, yeah.
If, yeah, I think that'd be great. So, pardon me, I'm just going to stop the recording here.